So the question is IPO. In this question, basically we have given two vectors, profits and capital. It means we can do, there are certain number of projects we can do which require capital I for ith project, and if we have done that project, then the total profit will be profits I. So basically these two vectors are telling this. Now initially we have some capital W with us, and we have whenever we complete one project, we will add the profit of that project in our capital, and then our capital will become increase. So we have to we have to do at most k projects in order to maximize our total capital, and we have to return that maximized total capital in the end. So the approach is, there are capital, initial capital, and the profit given to that. So we have an approach that we have to use the minimum capital project first, because we are limited by the W initial capital and we have only k projects. So we will do that project that will give us the maximum profit. So we will keep a vector of pair int comma int, in which we will be inserting capital comma profits in that vector, and then we will sort that vector. That vector will be sort according to the capitals. So the capital which is low will be at the starting, and high capital will be at the end. Now we will take a priority queue, max heap, to insert the profits, to insert the total profits in our priority queue. Let's suppose we have to do k projects. So let's suppose we will iterate a loop k times. We have initiated an integer total profits first initialized to W, and j is equal to 0, which is an index that is iterating over the vector we have created and checking if the capital of that project is less than equal to total profits, So we will iterate in the loop for k times. Firstly we will increment the value of j, and for each capital, for each project in which the capital is less than equal to total profits, we will add that project's profit in our priority queue, because we can select from that the maximum profit, we can select from that. Then we will check if the priority queue is empty, we will break the loop, else we will simply add top element of priority queue in the total profits and pop the element. So after this loop we will return the total profits. So basically what we are doing is, we are simply looking for, we have sorted the array capital from low capital to high capital. Initially we have some capital W, and all the projects that require capital less than equal to W, we can first use those projects. So while iterating in the loop k times, firstly we will add the profits of all the projects in the max heap, which we can take. By taking, it means that their capital is less than equal to W, or the total profit we have taken a variable. Now check, after this all the profits of projects which we can take with that initial capital are in the max heap. Now simply check, if max heap is empty, means there are no project whose capital is less than equal to W. So we will break the loop and return the total profits. Else we will check, because the max heap is not empty. So we will take the top element and increment it in the total profits, because that is the maximum profit we can have till now. Then we will pop that element from that. In the next iteration, because we have updated the total profits variable, incremented it with the profit. Then again, while iterating in the loop next time, we will check if the capital of the projects, we will check for all the projects whose capital is less than equal to total profits, and will add all those projects profit in our max heap. And simply we will again check if the max heap is empty, then break, else add total top element in the total profits, because that is the maximum profit we can have, and pop that element. So in this order we are taking the maximum profit value, maximum profit project, and also whose capital is less than equal to total profits we are taking. So in this way it is the approach we are using. So first we have sorted the array, so it takes n log n time, and then it will take, because we are pushing in the priority queue, it will take log n time, and we are doing it for k times, because the loop is running k times. So the complexity will be n log n plus k log n. So this is the total time complexity, and space complexity will be O of n, because we have taken an extra vector of pairs to insert our capital comma profits.